Let's take a look now at how a house of quality or the QFD process can be juxtaposed or butted up against your engineering process. As I've been saying, the engineering of your system itself requires tools, techniques, and models that are separate from the house of quality or the QFD. So this is just a demonstration using a SIPOC as my modeling technique. Interacting perhaps with process maps in a Six Sigma kind of mode. But I'm only using the technique as an example to generate the requirements that I then want to map into my house of quality. So don't take this as house of quality only follows the SIPOC. Just SIPOC is one example of many, many, many techniques you could be using to try to conceptualize your system over time. So if I'm using a SIPOC kind of approach, a supplier and customer kind of model, I need to know who my suppliers and customers are as I go through my process. Again, I'm not going to make this a primer on SIPOC, but we want to look at SIPOC as our example as we go through. Okay, so I'm going to be defining in a SIPOC my inputs and outputs and how I'm going to do that against my process map. So whatever engineering disciplines I want to use to model the processes, to model the flows, to look at how the different components converge on my process map, that ultimately in the SIPOC, the way the requirements work is I'm going to plug my requirements into the SIPOC such that I can interpret the columns of the SIPOC a certain way. So there's the process column, the supplier column, the input column, and the requirements column. So I want to phrase things in my SIPOC so that it's true that I can put the pieces together to form sentences. The process wants the suppliers to provide inputs that satisfy the requirements. So if I'm always following that form, I'll get the right requirements built into my SIPOC to be able to drive my system. If I don't follow that form, I run the risk of writing some bad requirement statements that kind of wander outside the scope of what I'm doing. But if I stick to the correct form, I'll get well-formed requirements that can truly be implemented by my engineering design. When I'm putting all this together with my processes in my engineering, typically the individual outputs at the SIPOC level represent a lot of convergence of various kinds of additional outputs I'm making from all over my system. So it's not true that one component of my system will output the SIPOC requirement. The SIPOC requirement for the output might be the consolidation of lots of outputs coming out of my system. I view it in terms of plumbing. I've got a sewer line leaving my home, but the sewer line isn't directly connected to any of my processes. I have drains all over the house, and they bring water together, and eventually it all goes out through my output. So the SIPOC output can be the culmination of lots of individual converged outputs that are being created from all over my system. It's a cumulative effect as I see my way through. Likewise, on the input side, I want to be able to make very similar statements. The customers want the process to provide outputs that satisfy the requirements. So on the output side, on my output requirements, I want to make things work in that way. My inputs can diverge as I come through the system, as I worked out going from noise to standard procedure to controllable. Again, going back to my plumbing analogy, the input might be the water main, but the water main doesn't connect to anything in my house. It diverges out into plumbing supplies and faucets all over my house. So the input isn't necessarily the thing that one component of my system needs. It's actually something that will diverge to flood the need. So I could have one input coming in from a given stakeholder, and that input might be diverging out and being used by lots of different process components in my system. So that's all part of what I do when I analyze the requirements in that way. So primarily, to go into my house of quality, I'm interested in what my customers are going to get. So I'm going to look at my output requirements. So I might be writing requirement statements like, financial reports are timely, financial reports are accurate. When I do that in a SIPOC, I tend to separate the output from the requirement, as you see on the bottom of this example. So timely and accurate financial reports. So it's the same information in the SIPOC as if I were just writing the requirements outright, but I'm trying to get down to that level where I'm looking at the requirements for my various outputs for my customers. I can have general examples like financial reports that are timely and available on time. On the top version, or I can get more concrete and specific, where I say I want financial reports that are timed to the prior day close of business or available by 8 a.m. So the lower examples, what a lot of requirements, methodologies, and standards require you to try to get as specific as you can and make them very, very measurable as you go through. So the problem we run into is that it's difficult for requirements to evolve over time if I'm specifying them in such precise ways. So what we want is a way to specify a general requirement, but to have a way to represent today's current target in terms of numbers we may want to improve over time. So one of the ways I can do that is to split them and use my house of quality to set my targets. Leave my SIPOC requirements very, very high level, timely and available on time, so that my QFD, my house of quality, my needs are for timely financial reports and available financial reports. That matches the SIPOC requirements. And the house of quality is a normal routine way to set targets for those values. So the prior day close of business and by 8 a.m. on work days becomes the target for those two needs. So adding the house of quality to my framework expands the range of parameters that I'm able to define in a very formal way, allowing me to separate, or not hard code, if you will, the target values from the requirements. I still have my target values, but now they're separated from the requirements. So over time, into the future, I'll always want timely and available financial reports. But the specific target I aim for over time might be different as times evolve and I can keep to improve my processes. In fact, if I take those targets out of my QFD and work on them in design in a subsequent phase, I'm very likely to want to be able to play with that over time. So if I know that I need financial reports by 8 a.m. on work days, I have a variety of trade-off analyses that I can do during my engineering to optimize how I'm going to do that. If I want an 8 a.m. and target upper spec limit on my days, what target should I aim for and how will I work that process out? So target design A here is a 3 sigma process where I aim for 7:30 and try to design for a sigma of 10 minutes. That's probably the easiest of all these constructs. Maybe the second one, B, is easier. It's the 7 a.m. start with a 20-minute sigma. All the way over the design target E, where I want to deliver 6 sigma quality, only having to target 7:30 a.m. And I can do that as long as I can get my design sigma down to 5. So by looking through my different trade-off alternatives for my optimization, I'm able to know what kind of timing target do I need to set for those financial reports. You don't set a target of 8 o'clock if you have to achieve 8 o'clock. My target's going to be 7 a.m. or 7:30 a.m., depending upon what I think I can do as my design sigma. And I can keep that interval short if I think I can design a system with a low sigma, but those are the things I'm going to have to trade off as I go. All 5 of these design options would meet the requirement, but their relative cost and impact on other factors would have to be evaluated. And that kind of trade-off analysis is what House of Quality and QFD is very good at. So SIPOC doesn't do any of that. So once I record a fixed hard-coded requirement in the SIPOC, I'm really done using the tools. But if I use the right tools in the right way, including a house of quality and quality function deployment, then as my design cascades through, I can come up with design alternatives at each level that allow me to do the necessary trade-off analysis, and my engineering will improve.